Hello students, welcome back to my YouTube channel. This is Kashima Soni and today we are going to start a new chapter, that is mass spectrometry. Correct, you heard that right. Mass spectrometry, not mass spectroscopy. So why are we not using the term spectroscopy over here? See, by spectroscopy we mean that we are introducing our sample with some sort of electromagnetic radiations. For example, we use infrared radiation in case of your IR spectroscopy. We use ultraviolet radiations in case of your UV spectroscopy. Correct. We use radio frequency waves in particularly in your NMR spectroscopy. Correct. So that is one thing, and all these techniques that I have mentioned over here, that is NMR, IR and UV, they are non-destructive technique because you are going to get the sample back. Okay, you are going to recover your sample. You can recover your sample in those particular techniques. So those techniques are non-destructive techniques. While we are talking about mass spectrometry, this is your destructive technique. This is known to be your destructive technique because you are not going to get back your sample once introduced in the mass spectrometer instrument. Correct. So that is one thing about it, the concept behind the naming of mass spectrometry and not mass spectroscopy. Correct. So let's see what are the topics that we are going to cover in this particular chapter. That is your basic principle, where we'll be discussing the elemental theory, molecular ions, isotopic ions or its peak. Then we'll be taking the fragment ions of odd and even electron type. We will be discussing nitrogen rule. We will be also taking up Stevenson's rule and index of hydrogen deficiency. And yes, we will be discussing all those things that are related and that are required to solve the mass spectrometer related questions. Correct. Then we'll be taking up the fragmentation techniques, the factors that will be affecting cleavage patterns, simple cleavage and cleavages related to heteroatoms. So these are the few topics that we are going to take up in this particular chapter. Correct. So starting with the same, that is your mass spectrometry. See what it is all about. Your mass spectrum. Let's see. I have already told you what is mass spectrometry. Correct. If you have not understood it once, I'll be repeating it again for you. That is that you are going to know about the molecular weight of the sample provided to you, and you are going to differentiate your given chemical compound or given chemical organic compound on the basis of your mass by charge ratio. Correct. You are going to differentiate its fragment ions mass on the basis of the mass by charge ratio. So ultimately you will end up getting the molecular weight or formula of the compound. Okay, that is one thing. And mass spectrum, it is the graph. What it is? It is the graph plotted between your mass by charge ratio or relative abundance of the ions. Okay, that is one thing. So relative abundance that you will be taking on the y-axis, and your mass by charge ratio that you will be taking in your x-axis, like this. Correct. What is happening? Let's say the basic principle. What is happening actually? The basic principle of this technique is basically to generate ions. Okay, you will be providing it with the neutral molecule, and you have to introduce it into the sample via sample inlet. In your instrument via sample inlet. Okay, you will introduce your sample in it via inlet, or you will inject the sample into it, and what will happen in the source, it will get converted into your gaseous phase, and your gaseous ions will be passing via analyzer, and through detector they will get detected on the basis of your mass by charge ratio. Correct. So that is how you are going to obtain your mass spectrum. That is the basic thing. So the basic principle related to it is to generate ions, okay, from either inorganic or organic compounds by any suitable method that we will be going to discuss in the next part, that is ionization method, so as to separate these ion on the basis of mass to charge ratio that I have already told you, and to predict them qualitatively and quantitatively by the respective, again, mass by charge and relative abundance. So that is one thing that we have discussed over here. Correct. Right, so you can see the structure that I've shown you over here. You are injecting your sample via the inlet, you are introducing it into your instrument, and then you are converting the neutral molecule into your gaseous atoms, which is further converted into ions, and then via analyzer, you will separate the fragment ions on the basis of mass by charge ratio, which will be detected by your detector, and ultimately will be recorded like this. The spectrum obtained would be like this. Correct. So that is one thing about it. Continuing about the overview part, you can see the mass spectrometer has 5 components that we have discussed. Now let's take up it into your detail. The first component would be your sample inlet, which brings the sample from the lab environment, that is 1 atmospheric pressure, to the lower pressure of the mass spectrometer. That is one thing. Okay. Pressure inside the mass spectrometer ranges from a few millimeters of mercury in chemical ionization source to a few micrometers of mercury in the mass analyzer and detector region as well. So you can see प्रेशर जो आपका है मास स्पेक्ट्रोमीटर से स्पेक्ट्रोमीटर के बीच में, it can lie from the range of from few millimeters to micrometers of mercury in your mass analyzer and detector region. That is one thing. Okay. And sample inlet, it leads to ion source. You can see ये जो आपका sample inlet है, यहाँ से आप देख रहे हो आप, it leads to the ion source जहाँ पे ionization होगी आपके sample की, where your sample will get transformed into gas phase ions. Okay. Then they are accelerated by electromagnetic field, and what will happen by mass analyzer, you will separate the sample ion based on their mass by charge ratio that I've already told you. Then what will happen, your ions, they are then counted by the detector and the signal is recorded and processed by the data system, typically a personal computer. So that is how your that is a kind of working of your mass spectrometer, kind of your overview. Okay. Continuing further, so samples studied by mass spectrometer, it could be of sorry, it is not glass, it is gas, liquid or solid. Okay. And enough of the sample, it must be converted into vapor state so as to obtain the stream of molecule that must flow into your ionization chamber. Okay. And with gases, what will happen? The substance already vaporized, correct? You need not to convert that particular sample into gaseous phase because it is already vaporized. Okay. So your sample inlet system can be used. A simple inlet system can be used. Okay. Now, this inlet system is partially evacuated so that ionization chamber itself is at lower pressure, and then the sample inlet system. Okay. Well, then further what will happen? If you have to ensure a steady stream of molecule that is passing into ionization chamber, what will happen? Your vapor will be traveling through a small pinhole, that is your molecular leak. That small pinhole is known as molecular leak before entering into the chamber. So the same system, similar system can be used for your volatile liquid as well as solid. Okay, so that is the system that we were discussing for your gases. Similar system could be used for your liquid as well as solid. So that is one thing. Now let's just switch to the another part of the topic, that is ionization method. And most of the time ये आपके जो subjective papers होते हैं, कई बार पूछ लिए जाते हैं क्वेश्चन. कई बार वो आपको सिर्फ इलेक्ट्रॉन आयनाइजेशन या सिर्फ केमिकल आयनाइजेशन पूछ सकते हैं, या कई बार आपसे डिफरेंसेस में पूछ सकते हैं ये क्वेश्चन, लाइक मोल्डी एंड फैब, एंड आपके पास टेक्निक एक और पढ़ोगे आप, सिम्स एंड फैब, वो आप पढ़ेंगे डिसॉर्प्शन आयनाइजेशन टेक्निक में, एंड कुछ भी आपसे पूछ सकते हैं इसमें से. सो लेट्स डिस्कस ऑल दिस इन डिटेल वन बाय वन, टेकिंग अप द फर्स्ट पार्ट, दैट इज योर इलेक्ट्रॉन आयनाइजेशन. ओके, so what is happening once the sample molecule has entered the mass spectrometer? Your sample molecule must be converted into charged particle by the ion source. Okay, so first of all we are taking up the ionization method over here, and the first method would be of your electron ionization. क्या होगा इसमें? सबसे पहले जो आपका सैंपल मॉलिक्यूल है वो सैंपल इनलेट के थ्रू एंटर कर जाएगा मास स्पेक्ट्रोमीटर में, और जो सैंपल मॉलिक्यूल होगा, फर्स्ट ऑफ ऑल एज वी ऑल नो, यू हैव टू कन्वर्ट इट इनटू वेपराइज्ड स्टेट एंड अल्टीमेटली इनटू चार्ज्ड पार्टिकल via the ion source before they can be analyzed and detected. That is the first part, obviously. And the next thing would be the simplest and most common method being your electron ionization, जिसे आप electron impact method भी बोलते हो, electron impact mass spectroscopy या फिर electron ionization mass spectroscopy. क्या होगा? Your beam of high energy electron is emitted from the filament. I can show you like this. So क्या होगा यहाँ पे? You can see the particular diagram over here. जो आपका beam of electron है from this filament, इसे हीट करने पे आपके इलेक्ट्रॉन इमिट हो रहे होंगे जो स्ट्राइक करेंगे आपके मॉलिक्यूल के साथ. ओके, लाइक दिस सैंपल इनलेट से आपने मॉलिक्यूल डाल दिया और फिलामेंट के से आपके जो इलेक्ट्रॉन इमिट हो रहे हैं वो कोलिजन करेंगे उनके साथ. ओके, so what we have discussed, the high energy electrons strike the stream of the molecule that has been emitted from the sample inlet system. And after then what is happening? Electron molecule collision will occur, which leads to the stripping of electron from that molecule, creating a cation. Okay, so that is one thing occurring over here. What is happening? Your sample, any of the sample molecule having mass m, is introduced in in where your filament is placed, which is for the rejecting electrons, and on collision of this sample having mass m with the electron, it leads to the formation of something like this radical cation. Okay, like this. So that is one thing over here. Okay, so what is happening, this electron molecule collision will be stripping an electron, as I've shown you, like this, and it leads to the formation of a cation, or you can call it as radical cation. Okay, that is your radical cation. Correct, that is one thing over here. And the repeller plate, what it will work like, it will carry the positive electrode potential, which is directing the newly created ion toward the series of accelerating plates. जो आपकी repeller plate है, which carries positive electrode potential, वो क्या करेगा, वो आपके newly created ions को direct करेगा in the direction of your accelerating plates. Okay, then what will happen, your large potential difference, that is ranging between 1 to 10 kilovolt, would be applied across these accelerating plates, producing a beam of rapidly traveling positive ions. Correct. So that is one thing happening over here. And ये जो आपकी focusing slit होंगी, वो direct करेंगे आपके ions को into a uniform beam. Okay, like this. So इस तरह से आपके ion via repeller plate and accelerating plate से होते हुए वो it will be reaching to your analyzer part, where your mass would be fragmented ions of mass having mass m plus or m2 plus, any of the fragment ions having masses like these would be differentiated on the basis of mass by charge ratio over here, which will be detected by a detector and ultimately will be recorded on your personal computer. That we have discussed in the basic principle only. So the instrumentation, the basic principle of all the instrumentation will be going to remain same. All you have to learn, if you are able to learn the first part, that ultimately you are able to understand the rest of the three parts as well. Okay, so you know, your most of the sample molecules over here, they are not actually, all of them, they are not ionized at all, but they are continuously drawn off by vacuum pumps that are connected to the ionization chamber. Some of them can be converted into negative ions as well. And the repeller plate, what it will do, it will absorb those negative ions. Correct. And it is also possible for you to reverse the polarity of repeller as well as accelerating plate in some of the instruments. Okay, so that is also occurring over here. So a beam of electron, it doesn't create ions with high efficiency until it strikes a stream of molecule with potential of about 50 to 70 electron volt. Okay, and now this is all about it. So basically what is happening, you have replaced your electromagnetic radiation with beam of electron in the case of mass spectrometry. Okay, right. So that is one thing occurring over here, and the energy of electron beam, it must be greater than that of ionization of organic molecule, which is around the ionization energy of organic molecule, which is around 18 to 13 electron volt. Okay, so that is one thing occurring over here. And let's discuss about the advantages and disadvantages of your electron ionization. See, it has some distinct advantages. For your small organic molecule, you can this particular technique is inexpensive and robust, and the kinetic energy, excess kinetic energy used, imported to the sample during this process, it leads to the fragmentation of ions. You will get the fragments. Okay, and it also has some disadvantages that includes your compound fragment so easily that the lifetime of the molecule is too short to be detected by your mass analyzer. That is one of the greatest disadvantage of this technique. And another one would be that the sample must be relatively volatile so that it can come in contact with the electron beam. Otherwise, for non-volatile compound, you're not going to use this particular method. Okay, so that's all that we are going to take in this particular video, and rest of the ionization method I'll be taking up in the next video. And if you have any sort of queries related to the same, you can mention it in the comment section over here. So yeah, that's all about it. And please just keep hooked to this particular chapter. If you want more videos related to the same, I'll keep on updating, I'll keep on posting every day. And yeah, that's all about it. Thank you. And yes, do not forget to subscribe my channel and continue showering your love as well. So yeah, thanks again.